Hi, I'm Miss Boom. Let's explore graphs of the form y equals x squared plus c. So in the previous example, we had a look at y equals x squared, and we're going to use that to compare what happens if we add c to it. So let's say we add 2. So let's c be equal to 2. What happens to our values? So x squared plus 2. So if x is -1, -1 squared is 1, plus 2 is 3. And we can work out all the other values as well. And we can use x squared already worked out there and just add 2 to each value. So 0 now becomes 2, 1 becomes 3, and 4 becomes 6. Now let's sketch x squared. And now let's sketch y equals x squared plus 2 and see what happened to the graph. We can see that when we're adding 2 to the graph, the whole graph has moved up by 2. The way to describe move up is to use the word translation. So instead of saying move up, we say translated up. So this graph has been translated up by 2. Let's look at the attributes of the graph and compare them to x squared. So the y-intercept has been moved up by 2, so it's 0, 2 now. There's no x-intercepts anymore. The axis of symmetry has not changed, and the turning point has moved from 0, 0 to 0, 2. We can observe that when our value c is greater than 0 or positive number, it moves the graph up or translates up. So all the points have been moved up by that value too. What happens if c is a negative value? Let's have a look. So we can sit there and work out all our y values by substituting x into the equation. And we can plot x squared, and then x squared minus 1 will look like that blue line over there. So it has moved down 1. So the y-intercept is now 0, -1. There's two x-intercepts, -1 and 1. The axis of symmetry has not changed. The turning point has changed to 0, -1. So we can see that when c is less than 0 or a negative number, it translates down. In other words, it moves down. Example 3. What happens if I have a negative graph and then I add 4 to it? So a negative graph will look like that, negative x squared. And when I add 4, it means I have that whole graph, copy paste it, and move it up 4. So the y-intercept has changed to 0, 4. Now we have two x-intercepts, -2 and 2. The axis of symmetry has not changed, and the turning point has changed because it's now moved up to that point over there. So we notice that the turning point has the matching value of the translation. So take a note of that. So we say this graph has also been translated up because the value c is greater than 0. What happens if we have negative x squared with a minus c value? So -5, for instance. So negative x squared looks like that, and -5 means we translate down. So it's like copy pasting the graph and pushing it down by 5. So the y-intercept has moved down by 5. Now there's no x-intercepts because it's not touching the x-axis. The axis of symmetry hasn't changed. The turning point has moved down to 0, -5. So see, the turning point has a matching number. And we describe this graph as c is less than 0, see? And we describe this graph as translated down. Let's see if you can match the graph to the equation given over there. Pause the video and unpause when you have figured them out. Here we have a positive graph and it's moved up. Here we have a negative graph. If you've forgotten how to distinguish between positive and negative, imagine there's two eyes on top there. So this is a negative graph that has been moved up. This is a positive graph that's moved down, and this is a negative graph that has been moved down. This equation +5 means it's moved up and it's positive, so it's that one there. This equation is a negative graph, +5 means it's moved up, so it's that one there. This equation is a negative graph that has moved down, so it's that one there. And this last equation is a positive graph that has been moved down because of -5. So these two graphs had translated up, and these graphs have been translate it down. Thank you for watching, and make sure that you revise the word translation, and I'll see you next time. Bye!